Analytical and graphical testing of the normal distribution of data. Introduction. Knowing the normality of quantitative data is a prerequisite in choosing the appropriate statistical tool. It is the underlying assumption that, in parametric testing, the normal distribution of data shall be established to make accurate decision or prediction. The need to know the normal distribution of data. In hypothesis testing, appropriate statistical tool is a must in analyzing the gathered data. The distribution of data is the basis of using parametric or non-parametric test. If data are normally distributed, use parametric test, otherwise, use non-parametric test. Goodness of fit test. The chi-square goodness of fit compares your data from expected normal distribution. It will tell us that if the p-value is less than 0.05 or 5%, we say that the data is significantly different but will not tell if the distribution is normal or not. Note that there is no absolute normal distribution. Shapiro-Wilk test. The Shapiro-Wilk test is the most accurate test for small sample sizes. This test will tell you if the data is normally distributed or not. Testing the normal distribution of data can be done by doing the following. 1. Analytical. 2. Graphical. These are just some of the approaches to have an idea about the distribution of the gathered data. For the analytical approach, we have Kolmogorov-Smirnov test, Shapiro-Wilk test, Anderson-Darling test. In these tests, the null hypothesis says that the data are normally distributed. This null hypothesis can be decided by determining or using the p-value. If the p-value is smaller than 0.05 or 5% significance level, the normal distribution of data is not assumed. However, if the p-value is greater than 0.05 or 5% significance level, normal distribution is assumed. In analytical testing, the sample size matters. It can be noted in the illustration that the p-value gets smaller as the sample size gets bigger. This means that, in analytical testing, there is a need to increase the number of sample size to have a smaller p-value to support the rejection of the null hypothesis and get rid of committing the type 1 error. However, the research design may also matter. If the research design is within subjects, the sample size may not matter. Visually, the normal distribution can be seen through the graph. Histogram and quantile QQ, plot can be used. The histogram with bell-shaped graph indicates normality of the distribution of the data points. The QQ plot shows that the data points are within the line of best fit. There are no observations situated far from the line of best fit. This indicates that the data points are normally distributed. Another approach in establishing the normal distribution of data. Use MS Excel for parametric measures. Mean, median, kurtosis, skewness. The mean and median. Using the data analysis tool in the Excel program, the descriptive statistics provides the mean, median, skewness and kurtosis. If the data are normally distributed, the mean and median of a normally distributed data are equal. However, this is rarely happening. In most cases, normally distributed data have almost the same or equal mean and median. If the graph of the test scores is negatively skewed, it means that most of the scores are high, only a few got low scores. The median is to the right of the mean, and the mode is to the right of the median. In a normal graph, meaning no skew, the mean, median and mode are the same, sometimes almost the same. while the graph which is positively skewed has a mean to the right of the median, and the median is to the right of the mode. This means that most of the scores are low, only a few got high scores. Kurtosis. Kurtosis refers to the flatness or peakedness of one distribution in relation to another. The term kurtosis refers to the statistical measure that describes the shape of either tail of a distribution, that is, whether the distribution is heavy-tailed, presence of outliers, or light-tailed, paucity of outliers, compared to a normal distribution. There are three types of kurtosis that can be exhibited by any distribution. Leptokurtic or heavy-tailed distribution, kurtosis more than normal distribution, k is greater than 3. Mesokurtic, kurtosis same as the normal distribution, k equals 3. Platykurtic or short-tailed distribution, kurtosis less than normal distribution, k is less than 3. It can be seen in the illustration that, if the kurtosis is 0, the graph looks perfectly bell-shaped. If the kurtosis is positive, the peak is high and the opening of the graph is narrow, while a negative kurtosis has low height and a wider opening of the graph. In descriptive statistics, the kurtosis value is displayed. If a kurtosis value is between -2 and 2, the data points are considered normally distributed. Thank you for watching. Please share this to the learners.